Hello class. So this video will be about lesson 8.8, talking about similarity and dilations, and our goal is to look through the similar polygons and find the missing measures. Vocab words for this particular lesson are similar polygons. So in order to have similar polygons, we have to have polygons with the same shape. That's very important. The shape should be the same. It doesn't matter about the size. So size could be the same or not the same, but the shape of the polygon will be the same. Dilation is a transformation that stretches or shrinks one shape. So if one shape is small and you do a dilation, it could become bigger, larger than the original. Or also if we have one large one and we want to shrink it to a smaller one, the shape will look like the same, but the size will be much smaller. And another vocab word here is a scale factor. Scale factor normally is represented by ratio of side lengths of the figure, which is the original one, through the image of the dilation. So talking about those vocab words, let's see what it looks like as an examples. So similar polygons. If we have similar polygons, triangle ABC and triangle XY and Z, that shows us, and now I want you to look at the two pictures because you're going to see two similar polygons, and the first one will be this polygon over here, and I'm using different color, and next polygon is this over here. We know those are triangles, but in fancy geometry words, we call them polygons. So if we have angle A, and this symbol means congruent, which means that both angles will be equal to each other. So in order to be congruent, angle A from here, from the first polygon, will be congruent to angle X of the second polygon. Same thing, if I have angle Y, and angle Y is this one over here, then the congruent to angle Y will be angle B. Those two are congruent. If we're talking about corresponding side lengths will be this side and this side, or this one and this one. So this is what we call side lengths, and normally we write those as a proportionals or ratios. So AB will be proportional to XY. AB, this one, is proportional to this one. They're not the same size, but they are proportional to each other. Also, we have given BC, which is this one, is proportional to YZ. So BC proportional to YZ, and XZ, this one, will be proportional to AC. AC proportional to XZ. So seeing all those things, we can just conclude that AB is proportional to XY, and also we can say that AC is proportional to XZ. So what you are looking for is only side lengths that will be proportional to each other's. And when we're talking about angles, then the angles can be proportional. They can be only congruent to each other. So saying these examples, talking about these examples, I want you to take a look of another example here. And we have another two similar polygons. So is this big one rectangle here and the one down here. And with these photographs, let's call those two photographs, they are different size but have the same shape. So we're going to tell what will be the similarity or how they correspond to each other. So the corresponding angles will be congruent angles, those that are congruent. Each angle we measure with, in this case, each angle will be 90 degrees angle. We can say that easily. It's a rectangle. So angle A, this angle will correspond to angle E. Then if I'm looking to angle F, then the corresponding to F will be angle B. Same, if I follow the same steps, and you can give a try now and think about what will be corresponding to angle H. So what do you think? Angle H, if you look at this shape, will be angle D. Exactly correct. You are right, angle D. And if I look angle G, the corresponding one will be angle C. So we're done with the angles, measure them, found the corresponding stuff. If you go down through this example that I'm giving you, you will see they're asking us what are the correspondent lengths are, and they are proportional. So proportional. Proportional are also, in other words, we're using ratio to express those. And they already set up something for you. They said, okay, if this side here is 18 inches, then 18 inches will be proportional to 6 inches because this one and this one are the two sides, length sides that we can set up as a ratio. And if we have 12 for this one and 4 for this one, then 12 over 4. And remember, if you start with this number first with the larger, you put the smaller on the bottom. If you have larger on the top as well on the other side, then smaller on the bottom. You can't mix up those. So don't write 18 over 6 equals 4 over 12. This will be wrong. You want to have larger to smaller, larger to smaller, following the same pattern. So 18 over 6 is 3 inches, and 12 over 4 is also 3 inches. So when you simplify those two ratios and you get that left side is equal to the right side, this is what tells us, yes, now we have proportions, and those two polygons are similar because of their angles and because of the size of the side given. Alright, so that was a quick one. Now I'm going to show you one more example of this measurements, which could be a real life example, and then I will let you practice with the rest of the examples. So we have indirect measurement here. Height of a building is 25 feet. So here's the building, this is the height, 25 feet tall, and casts a 10-foot as a shadow. So the shadow of this building, sometimes during the day, is 10 feet. At the same time, a fence, so this is the fence here, is a 6-foot tower, and also 6 feet will be the shadow of this fence. Now, in order to work the solutions, they're asking us to find the height of the fence. So look at the question. Find the height of the fence. Well, okay, well, let's see what we can do. We know that those two shapes, polygons, including the height and the shadow, express triangle. They are polygons, same, not equal to each other, but we will be able to write the proportion and ratio to find what x, or this part, is equal to. So we can send the proportion fence height, this is the fence height, through the building height. So I will just put building height here. Okay, and then we have the length of the fence shadow through the length of the building shadow. Alright, so if I go from here to here, my equation will be, starting with this smaller amount, x through the larger 25 is equal to, and again we start with the smaller, through the larger, which is 10 feet. Well, when we set a proportion like that, just a few days ago we learned about cross-product method and how to solve equations, just like when we did with the percentage. So we're going to use this cross-product method and we will multiply, and we're going to write x times 10 as 10x equals to 6 times 25 will be 150. Well, one more step here to get what x is equal to, we just need to divide by 10. So x will be 15, which means this fence height will be 15 inches. So we just got the answer of this example. So the fence is tall 15 inches. And with this, my problem is completed. So that was pretty much all about lesson 8.8. Definitely, if you have more questions, we will discuss them in class as well. But hopefully, that will help you to start with your work and be ready for completing. Thank you for watching the video.